Okay, these next series of questions, we're going to take our standard z-score formula. Z is equal to x minus the mean divided by the standard deviation. Now in class I showed all the algebra behind this, but I want to simplify these videos. So we're going to do some algebra. We'd multiply both sides by the standard deviation, then add the mean. We're going to solve for x. And if we do that, we get a new formula. X is equal to the mean plus z times the standard deviation. Z times standard deviation. Okay, and this is the formula we're going to be using throughout these next series of questions. So 34, we're giving that it's we've got a variable normally distributed, so something we're measuring. It has a mean of 2 and a standard deviation of 6. What is the x value for a z-score of 3? So we're going to use this again. So what we were told is the mean is 2. We're looking for the x-score. The mean is 2. Standard deviation is 6. So we add that to the z-score is 3 times standard deviation of 6. 3 times 6 is 18. 2 plus 18 gives us an x-score of 20. Let's continue on and see how this works with 35. Okay, 35, we have a mean of 8, a standard deviation of 1, and a z-score of negative 2.25. So again, we use the formula. We're looking for the data value, x. The mean is 8. We're going to add z times the standard deviation. Z is negative 2.25. Standard deviation is 1. 1 times negative 2.25 is still negative 2.25. So 8 minus 2.25 gets us to 5.75. That's the x. That's the value of the data, the piece of data. 36. We again have all this information. The mean is 4, standard deviation of 2. What is x? If it's 1.2 standard deviations to the left of the mean. To the left of the mean is going to be negative, not positive. So we put in everything we know. The mean is 4, so we put 4 plus the standard, or the z-score, which is 1.5, but since it's to the left, we make it negative. And then the standard deviations is 2. The data value of is 2 data values. So when we multiply all this out, we get 4. This is going to give us a negative number, minus 3. 4 minus 3 is 1. 1 is our data value. X is 1. 37. Again, a similar setup. We're looking for x. We're given a mean of 4, so we put that in. We're going to multiply by the z-score, which we are told is 2 standard deviations, or that x is 2 standard deviations to the right, so that z-score will be a positive 2. Emphasize that. And the standard deviations is 2 data scores. So this gives us, equals 4 plus 2 times 2 is 4. So that's going to give us a data value of 8. Okay, so that's how, if we have the z-score, we can use the mean and the standard deviation to calculate the data score. If we have the data score but need the z-score, we use this formula up here, and that will get it for us, just like we did in the previous problems. So let's take a look at one applied problem here, number 39, similar to the problem with the blood pressure that we did earlier. Okay, so you can read through this. The key parts of question number 39 are that we have a mean of 79 and a standard deviation of 3.89 inches. You might we'll convert them to feet when we need to, just to understand exactly, put the height into perspective. So the A question, we are being told that some player is reporting that his z-score of his height is 3.5, and would you believe him? Well, if his z-score is 3.5, but we want to find out what is his height. So that's just like these problems we've been working here. We're looking for the data value of x. We're told that the mean is 79. He's saying that it's 3.5 above. And we multiply by the standard deviation, which is 3.89 inches. When we multiply all this together, we get that x is 92.6 inches. There's 12 inches in a foot, so if you divide that by 12, you'll get that this person would have been 7 feet tall. 7 times 12, if you take 7 times 12, you get 84. Subtract that from 92, and that gives us 8.6 inches. Now we'll have another section where we actually go through conversions. We'll talk about it at that time, but 7 foot 8 inches, almost 7 foot 9, that seems very tall, but remember, basketball is a game of tall people. I know this because I'm not an NBA player, just put it that way. So I would say, sure, I'll believe him. He's certainly maybe at the outlier at 3.5, but I could believe if someone was basically 7 foot 9, they would probably be in the NBA. Again, they need some other skills too, but anyway, I would say I will believe him because it's a game for tall people. Back of the answer says they didn't believe him, but this is an opinion part. Yes, I do believe, because b-ball is for tall people. Now the B question, someone else says that they're negative 3.5, that's their z-score, so they're 3.5 below the mean. We could go through this same calculation. Basically, it's going to be the same, except here we're going to be subtracting, right? So let's switch off colors. So x is equal to 79 is the mean. The z-score, they're saying, is a negative 3.5. Multiply by 3.89 inches. And when we do the math here, all in our calculator, we'll get that x ends up being 65.4 inches. Convert that to feet, divide by 12, you'll get that's 5 foot. That gives you 60 inches, and then there's 5.4 inches left over. Now, while there have been some people of maybe this height or shorter people who do well in basketball, there's probably not that many NBA players that are only 5'5". I'm about 5'9" or 10 if I stand up straight. I would not fit in the NBA. So this one I would say, yes, it's way out there as far as standard deviations, and probably unlikely. I would say this one I wouldn't readily believe unless I saw some pictures, some video. So this just seems too short. For NBA. However, sometimes they do these things as a publicity stunt. So you never know, but it probably doesn't work well.